Today we'll be looking at lesson 8, equivalent ratios defined through the value of a ratio. Now remember, a ratio is a comparison of two values. Okay, and then the value of the ratio is just dividing those two values, or finding the quotient of those two values, which we often write as a fraction. So let's start by looking at exercise 1. Circle any equivalent ratios from the list below. Well, there's 4 ratios there, and there are 2 sets of equivalent ratios. The first 2 are equivalent ratios. Why? Because we can reduce 5/10. You could reduce 5 to 10 by dividing both by 5. 5 divided by 5 would be 1. 10 divided by 5 would be 2. Remember, you can reduce ratios just like you do reduce fractions. So therefore, these 2 are equivalent. Also, 6/16 and 12/32 is also equivalent. You can reduce these as well. You could reduce 6/16 by dividing by 2, and you would get 3/8, 3 to 8. Whereas for 12/32, you can also reduce by dividing by 4. 12 divided by 4 is 3. 32 divided by 4 is 8. Therefore, both of these ratios can reduce down to 3/8 or the same ratio. So they are equivalent ratios. Let's see what happens when we find the value of these equivalent ratios. So the next section says find the value of the following ratios, leaving your answers as a fraction, but rewrite the fraction using the largest possible unit. Or in other words, reduce the fraction. So for the first one, 1 to 2 would become 1/2. We divide the first number by the second number, which would become 1/2. For the second one, 5/10, we would do 5 divided by 10, which would reduce to 1/2. Let's look at the third one, 6/16. Well, that'd be 6 divided by 16, which would reduce to 3/8, just like above. And lastly, we would have 12/32, which would reduce to 3/8 as well. So what do we notice about the equivalent ratios? Well, we notice that equivalent ratios have the same value. 1/2 and 5/10 were equivalent. Well, 1/2 and 5/10 both have the value of 1/2. 6 to 16 and 12 to 32 both have a value of 3/8. So we notice that all equivalent ratios have the same value. Okay, let's look at exercise 2. Here's a theorem. If 2 ratios are equivalent, then they have the same value. Can you provide any counterexamples to the theorem above, or find any examples that show that theorem is not true? So why don't you take a minute or two and see if you can think of or find 2 equivalent ratios that don't have the same value. You weren't able to find any because the theorem is true. All equivalent ratios will have the same value. That is what makes them equivalent. Since equivalent ratios can be represented by the same fraction, that means their value is always the same. Tavion is training for a duathlon, which is a race that consists of running and cycling. The cycling leg is longer than the running leg of the race, so when Tavion trains, he rides his bike more than he runs. During training, Tavion runs 4 miles for every 14 miles he rides his bike. Identify the ratio associated with this problem, find its value. So we're looking for the ratio of running to biking. Well, to find the ratio, we got to figure out how much he runs. Well, he runs 4. So the first number in our ratio is going to be 4. Then we need to find out how much he bikes. He bikes 14. So the ratio is going to be 4 to 14. Well, now we need to find the value of this ratio. Remember, the value of the ratio is just the quotient or the dividing of the two numbers. So 4 divided by 14. Let's leave it as a fraction, but let's reduce it if we can. So I'm going to reduce it, and to reduce it I'm going to divide the top and the bottom by 2. 4 divided by 2 is 2. 14 divided by 2 is 7. So the value of this ratio is 2/7. Next, let's use this to answer some more questions. Okay, let's use it to answer a few more questions about Tavion's training. When Tavion completed all of his training for the duathlon, the ratio of the total number of miles he ran to the total number of miles he cycled was 80 to 280. Is this consistent with Tavion's training schedule? Explain why or why not. Well, if we want to see if it's consistent or equal, we need to see if the value of the ratio 80 to 280 is the same as the value of the ratio from the before. Remember, we said the ratio from before's value was 2/7. So let's see if the value of this ratio, 80 to 280, is 2/7. So we first of all got to find this value unreduced. Well, let's do 80 divided by 280. Now we need to reduce that. And to reduce this fraction, we can divide by 40. 80 divided by 40 is 2. 280 divided by 40 is 7. So the value is 2/7. Well, if this value is 2/7 and the value before was 2/7, are those two ratios equivalent? Yes. So was his training consistent? Yes. Why? Because the two values were the same, proving that the ratios were equivalent, therefore making his training consistent. Okay, well, let's look at C. In one training session, Tavion ran 4 miles and cycled 7 miles. Did this training session represent an equivalent ratio of the distance he ran to the distance he cycled? Explain why or why not. Well, let's again take what we have, turn it into a ratio, and find its value. If those values are the same, it will be consistent. If those values are not the same, it won't be consistent. So we have 4 running to 7 cycling. So that's a ratio of 4 to 7. The value of that ratio is 4/7 because it's the quotient of those two values. We can't reduce 4/7 at all, so the value of this ratio is 4/7. Well, is 4/7 equivalent to 2/7? No. Therefore, it is not consistent because the value of the two ratios are not the same. So let's remember the important thing we learned in this lesson is that if the value of two ratios is the same, they are equivalent. If they are not the same, the two ratios are not equivalent.